So in this problem, we are provided with the equation of two circles, and we need to show that a line with the equation x plus square root of 3 times y equals to 4 is tangent to both of the two circles at the same point. Let us begin. So here, let's say we have a circle with center C1. We're going to represent C1 as the circle with the equation x squared plus y squared equals to 4. And then we have another circle C2. So C2 is going to represent the circle x squared plus y squared minus 4x minus 4 times square root of 3y plus 12 equals to 0. Now we'll consider a line. Let's call the line as tangent line. T is tangent to both the two circles at a common point A. Now that is what we need to show. We will first assume that it is meeting at the point A. So in order to solve this problem, we'll start with the circle C1 and we'll try to find out the coordinates of the center as well as the radius of that particular circle. We'll do that for the second circle as well. We'll start with C1. Now what we'll do, we will use the general equation of a circle. The general equation of a circle is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. Now for the first circle, we have 2g equals to 0, 2f will be equals to 0, and the value of c will be equals to negative 4. That gives us g equals to 0, f value equals to 0 as well. Now we can define the coordinates of the center C1. The coordinates of the center, which is generally defined by negative g comma negative f. So our circle is going to have a center at the origin. That means 0 comma 0 are going to be the coordinates of the circle C1. And the radius of the circle can be defined by using the equation square root of g squared plus f squared minus c. Now since g and f are 0, so we replace the value of c with negative 4 and the radius is going to be 2 units. Fine. We'll keep this aside. Let's come to the second equation of the circle. We'll consider C2. So here if we compare with the general equation, then 2g will be equivalent to negative 4, which means that the value of g will be negative 2. Then we have 2f equals to negative 4 times square root of 3, which means that f value will correspond to negative 2 times square root of 3. And then we have the c value, that's positive 12. Our coordinates of the center C2, which is negative g comma negative f, that's going to be, since g is negative 2, so negative g will become positive 2. Similarly, negative f will become positive 2 times square root of 3. That's going to be the coordinates of the center C2. And the radius will be given by, we'll take the square root, we'll square g, so that's going to give us positive 4. Added to square of f, so we have square of negative 2 times square root of 3, so that's going to be 12. And from here, we're going to subtract c, so that's 12. So this is also going to give us a radius equals to 2 units. The coordinates of the center C2 is going to be 2 comma 2 times square root of 3. Now in order to show that the line T is actually the tangent to both the two circles, what we'll do, we'll try to find out the distance of the center C1 from the tangent line, and also we will find out the distance of point C2 from this particular line. Okay, so here we're going to use a formula. Let's quickly recap the formula that we'll be using here. Suppose we have a point with coordinates x1 comma y1, and then we have a straight line whose equation is given by ax plus by plus c equals to 0. Now let's say we want to find out the perpendicular distance of this point from the straight line. Now this perpendicular distance is going to be given by the formula. We'll take the absolute value. In the numerator, we're going to consider ax1 plus by1 plus c divided by the square root of a squared plus b squared. All we have done is take the coefficient of x of the straight line and multiply with the x coordinate of this point. Then add it to coefficient of y, which is b, and multiply with the y coordinate of that point and add it to the constant c value and divide by the square root of a squared plus b squared. A and b are the coefficients of x and y of the straight line. We're going to use the same formula to first find out the distance C1a. So let us begin. So here we have C1a. This is the perpendicular distance that's given by, we'll take the absolute value. We are provided with the equation of this particular line. We have x plus square root of 3 times y minus 4 equals to 0. So we'll consider the coefficient of x of the straight line. So that's 1. 1 will get multiplied with the x coordinate of the center C1. So that's 0. Added to coefficient of y. So that's square root of 3. Square root of 3 gets multiplied to the y coordinate of the center, which is 0 as well. And we are going to add the constant term. So that's negative 4. Divided by the square root of 1 plus square coefficient of y square root of 3. Squaring it gives us 3. So this will be equals to, so here we have negative 4 divided by square root of 4. Now square root of 4, that's simply 2. We have negative 4 over 2, or we get absolute value of negative 2. We'll take the positive value, so C1a comes out to be 2 units. However, we have already showed that for the circle C1, the radius is 2 units, which means that C1a, the perpendicular distance, is nothing but the radius of the circle. And this tells us that the line must be tangent to the circle C1 at point A. Next, what we'll do, we'll try to find out the perpendicular distance C to A. Again, this will be using the same formula. So we will take the absolute value. Inside the absolute value, we'll start with the coefficient of x. So that's 1. 1 will get multiplied to the x coordinate of the center C2. So that's 2. Added to the coefficient of y, which is square root of 3. Square root of 3 gets multiplied to the y coordinate of the center. So that's 2 times square root of 3. And then we have the constant term added to it. So that's negative 4 divided by the square root of 1 plus 3. So let's simplify this value. So we have 2 added to the 2 times square root of 3 times square root of 3. That's going to become 6 minus 4 divided by square root of 4. Then we have positive 4 divided by 2, which gives us the value 2. So here also we're getting C2a, the perpendicular distance, equals to 2. And we found out this is equals to the radius of the circle with center C2. So this means that the line x plus square root of 3y minus 4 equals to 0 is also tangent to the other circle. All we have done here is show that x plus square root of 3y minus 4 equals to 0 is tangent to both the two circles. Our next goal will be to find out a point of contact A. So we will find out a point of contact A and show that it's going to be a common point for both of the two circles, meaning the line is going to be tangent to the two circles at the same point A. Now how shall we find out the coordinates of point A? So we will suppose that the coordinates of point A will be x1 comma y1. Now if it is x1 comma y1, we'll start with the circle C1. So let's write down the equation of the circle C1. So since we are considering the point A having the coordinates x1 comma y1, this particular point is going to satisfy the equation of the circle C1 as well as the tangent line, because the point lies on both the line as well as the circle, which means we can replace the value of x with x1 and y with y1 in the equation of the circle. This will get us x1 squared plus y1 squared equals to 4. And the equation of the line will become x1 plus square root of 3 times y1 minus 4 equals to 0. So here, if we isolate x1, so that's going to be equals to 4 minus square root of 3 times y1. So let's substitute the value of x1 with 4 minus square root of 3y1 in the equation of the circle. Then we will get 4 minus square root of 3 times y1 whole squared added to y1 squared equals to 4. Expanding this gives us 16 minus 8 times square root of 3 times y1 plus 3 y1 squared plus y1 squared equals to 4. Let's combine the like terms. We have 4 y1 squared minus 8 times square root of 3 y1, 16 minus 4, that's going to be positive 12 equals to 0. So here, this is a standard quadratic equation. We can use the quadratic formula to obtain the value of y1. The y1 is going to give us a value square root of 3. And if we use this equation, then the corresponding x1 value is going to be equals to 1. So here we have obtained the coordinates of point A. So that's going to be 1 comma square root of 3. Now, in order to verify that this particular point also lies on the second circle, then we can say what we'll do. We'll replace the value of x with 1 and y with square root of 3 into the second circle. Let's check it out. So we have 1 squared plus square root of 3 whole squared minus 4 times 1 minus 4 times square root of 3 times square root of 3 plus 12. we get 1 added to 3 minus 4 minus 12 plus 12, and when we sum it up, we get the value equals to 0, which is indeed the correct result. So that means we have successfully showed that the straight line given by the equation x plus square root of 3y minus 4 equals to 0 is going to be tangent to both the two circles x squared plus y squared equals to 4 and the other circle C2, and they are going to have a common point A with the coordinates 1 comma square root of 3.